Okay, thank you for attending my talk about Mozilla identification and access management systems. The name of the talk was chosen by a friend of mine who was like, hey, you don't have access to Mozilla anymore. Access denied for you, Michał. Well done. So I tried to log in a week or 2 weeks after I left the company. Apparently someone correctly logged my account, which is awesome. So the question why do we even need a custom identification and authorization system? Well, problem is nothing is obvious in an environment like Mozilla. Mozilla's boundaries are very unclear, and there is a lot of people working together that are not part of the organization itself. So, for example, there is a huge community around Mozilla, estimated to be like 5,000 people. That's what I heard. And many of these community people, they work together with a staff being people employed by Mozilla and getting salaries. And we were a very unusual company because Mozilla shares system outside of the organization. So if there is internal Slack in some bank, that's the internal Slack of this bank. For Mozilla, there are private channels, public channels, everything is shared between community and employees. This is a challenging environment with a need to co-manage identities of people from all around the world. So at some point, people started asking questions. How do we unify couple hundreds of systems that we have at Mozilla uses? And how to do a unified authentication with an unknown number of licenses. You know it when you are trying to buy licenses for some products. It's like, hey, how many licenses would you like to buy? And Mozilla would be like 1,200. But we might need 5,000 tomorrow, but we might need 700. We need maybe 10,000 a year from now, but for a month, and we do not really have enough money to pay for 10,000. So this kind of licensing issues give a lot of headache to every single vendor. And vendors were trying to come up with solutions, dynamic licensing. Maybe if your community member has not been active for a while, we will revoke the license, but we didn't want to. So basically, the problem was we cannot buy, there is no way Mozilla can buy a license for everything we use for every community member. There's just not enough financial resources, as you might have heard recently. So the project was born, and a very important part, it was not me. Like, I did nothing in this project. I just thought a couple of weeks ago when I was looking for something interesting to present at Confidence, that, hey, this identification management system is one of the successful projects. Maybe that's because I was not part of the project. So I took something from my colleagues, and there they are, 3 most important people on the screen and tens of others who helped. I was not part of it. I did nothing, literally. I'm just, as someone said, I'm an ex-engineer with a Stockholm syndrome. I no longer work there, but I talk about it. So what do I mean by we need to give a lot of Mozillians access to Mozilla systems? As you can see on a diagram, Mozilla staff, which is employees, are just a subset of what we call Mozillians. There are Mozillians who are volunteers helping develop Firefox. You can do it on the side. You can write add-ons. You can help writing the Mozilla Developer Network documentation, or work on the Rust language, or, well, as of recently, that's a separate organization, but still. And there's like tens of projects inside of Mozilla. Anyone from outside can help. And if you want to help, you need access to our internal systems to communicate with other volunteers, to communicate with staff. So the idea was to design a very unified identity system for whatever kind of Mozillian you are. So Mozillians, both from the community and corporation, can access any system they need to. So diagram time. Let's spend half an hour talking about diagram. Just kidding. But something important to show here. On the left, you can see what kind of people we are thinking about getting access to Mozilla systems. So that's volunteers, community, their staff, like I said. On the right, you have like the Mozilla login web page, which is our SSO web panel. This is what you get when you go to like sso.mozilla.com. If you feel like pen testing something, you know, there is bug bounty program. So you already know the address, just saying. And it is like a startup portal that verifies your identity. This portal talks to our identity provider and also Auth0. We use multiple identity providers. I will show it in a second. And we store information about who has access to what kind of systems in something we call Mozillians. This is the square that I'm trying to circle with my mouse. I hope that's visible. The Mozillians ones is like a database of all users, both community and staff. And there is also some corporation information for employers ingested from Workday. All of these sources of information, all of these sources of truth go into something that we call Change Integration Service, which is a service running in AWS using probably most of AWS technologies known to the world. It ingests a number of information about groups, who belongs where, who has access to what the permissions look like. It talks to our open LDAP for authentication and for storing passwords. It parses it sends every user session through Auth0, which is like a rule engine that I will talk about in a second. And after all of these steps are done, you can get access to one of our shared systems that we share with the world. So the goal was here, like you saw this diagram, and I talked a lot, and you are like, what? This is confusing. It's confusing and it's powerful. The goal here was to lower the barrier to participate while enforcing access to sensitive systems. So what do I mean by that? Lower barrier to participate, as you will see in a second, you can see on the screen here, you can log into many Mozilla systems, not just an employee with your LDAP password, but with your Firefox account, GitHub, Google, whatever. But we still want to maintain control over your identity and access to our systems. So what we did is, in a traditional system, you would have various login methods. Well, you would have one IDP. What is IDP? Identification provider, which is the glorified database, really, that stores all of the information about passwords and usernames. Nothing complicated about it. And we have ours as well. We store our usernames and passwords for staff and staff only in LDAP. But people from the community were like, I don't feel like creating another account with Mozilla just for you. I want to log in with my existing Gmail account. Okay. Or I want to log in with my GitHub account. Okay. Or I want to log in with Firefox accounts. Like, it does make sense. I have a Firefox account. I use it for synchronizing data between my browsers. I want to use it to participate in the Mozilla community. Absolutely. So we have multiple identity providers, as you can see on the left, and we divide them who is it for. So LDAP only keeps information about staff which are Mozilla employees. Everything else is for community, and community can choose one of these identities on the left here. Now, all of these come with various security levels, and we want to enforce minimal security level to access to, our systems. So we require that those login methods on the left have some minimal security levels on the right, like support for MFA. So we only accept your Google, or which is the Gmail login, if you have MFA enabled. Same for GitHub. If you don't have MFA enabled in your GitHub account, you will not be able to use it to access Mozilla systems. The passwordless option is interesting. You can log in just with by providing your email address, never create any special account, never remember any password. And when you want to log in, you provide the email address again, and it sends a link to your email that you click and you log in. So it's like using I forgot my password every single time. It's for the least secure systems that we don't really care much about. TLDR, you can log in into multiple Mozilla systems with many different identifications that you have. Now, we want a system that will be flexible, but we want a system that also enforces some minimal security level, right? It is not that we want to give access to everyone who has any random Gmail address and give them access to whatever Mozilla systems they sign up for. We want to assert some sort of trust. So we invented this concept. Well, we didn't really invent it, but we enforced this concept, kind of like you must be this tall to write. Like if you go with your kid to some playground and there are like various activities available and your kid is like 10 years old, and some of them are only available if the kid is like this tall enough or like has 12 years old. Otherwise, there is a risk to this kid, the kid cannot write. Kind of similar situation here. We enforce some minimal requirements on the authentication. And let me show you how it's done. So for every identification provider, we kind of collect something that we call assurance levels, and we enforce assurance level. So what is so when you are trying to log into, when you are trying, in the ideal world, when you are trying to log into Mozilla system with your laptop, which is on the right side at the top of the diagram, there would be like a agent running on your system that would be asking, hey, does this person that is trying to log into our systems, does this system have this encryption enabled? Is the system up to date? So asking questions, for example, about the machine itself, device, we call it device AAI. So like updated, encrypted, do we know this device from previous sessions? On the other hand, our system asks some questions about the user itself. So, for example, is the user trying to log in with identification method that supports MFA? Is the geolocation known? What is the geolocation like? Maybe it changed between user sessions. Those indicators, as we call them, assurance access indicators, are combined into something that we call assurance level. And this assurance level is a minimal bar that you have to pass if you want to log into a Mozilla system. So let me give you an example. You are trying to log into our chat website, like a discourse. So when you are trying to log into discourse, if you just want to chat on discourse, we will require that both your machine and your user session meets the low assurance level. Low being like, you have an account, have a nice day. But it only gives you access to chat on the website. But if you want to be like an administrator, you want to be in an administrator role, we will require the high assurance level to access the administrative panel of the same chat website. So we will require that you logged in with MFA from a known geolocation with a decent and known, updated, encrypted, whatever device. So system like this allows us to enforce a minimal level of security to access various systems. You can see an example, you can go to this link even if you want to look at it, how those various indicators are mapped into assurance levels. So for the low, it's like, yeah, if there was an account and there was no recent brute forcing on an account, we will let you in. For the medium security level systems, you also need to meet the requirement for 2FA, and the IDP needs to be high assurance, so something like GitHub, Gmail. For the high assurance level, we'd rather see the geolocation not jump all over the place, not jump all over the world, but could be an indicator of a compromise, like someone logged in from here, San Francisco, and 5 minutes later, someone logins from completely different part of the world, like somewhere in Krakow. And we would think, oh, this person might be not traveling that fast, either they use VPN, or maybe someone stole their credentials and is using them from somewhere else. So there is a plot twist. There is always a plot twist if you are trying to implement something in Mozilla. Remember me talking about the user agent on your device checking the security level on your machine? So when we proposed something like this inside of Mozilla, people were like, forget about it. Like, just no way. So we were like, we'll run this piece of code, small daemon, whatever, on everyone's laptop. And people were to tell us the state of your device. And people were like, no, you are violating my privacy. I'm like, what privacy is there if I'm just asking if your device is encrypted? No, you are violating my privacy. Okay, got it, got the message. So Mozilla internally does not use any verification of the end user device. Other problems that we encountered were that geolocation is super noisy, and it's very difficult to use geolocation for any reliable detection, especially in environment like Mozilla, where people use a lot of VPNs. Like VPNs are something that, like, I don't know, 70% of people use on a daily basis. And so we require MFA. That's like our assurance level. And if you are looking for an agent that would check the state of your device and communicate to your IAM system, there is one free for Google. There is a link in the presentation itself, and I will share those slides later, so you can get all of those links. Coffee time. And a wake-up time, if someone is sleeping already. Another feature is multi-step access verification. So not only just the identification provider decides on access to a system, but also the RP, which is the system that you are accessing, can decide as well. So a very simple diagram, really. You are trying to access, let's say, our MozDev, which is our SIEM, where we keep our logs for security and response. The first stage, which would be the sso.mozilla.com with all the complicated diagram, will just verify. Does the user have an account? Is MFA enabled? What is the assurance level? What are the generic groups of this user? And the generic groups are like, Michał is in EIS, Enterprise Information Security. We will let him in. So this is what the Auth0 authentication access provider decides on. Then authentication is passed on to the RP system, which is the system that you are trying to access, like Slack, Discord, MozDev. And this system can also decide on its own if it wants to allow user access or what kind of access should be allowed. So on a generic level, I might be at the first step allowed to access MozDev, but MozDev itself will decide I only have read-only access, or like access to a subset of data. Another feature, we wanted to be able to, in the process of authentication and authorization, enforce arbitrary transformation rules. What do I mean by that? You remember me talking about Auth0 previously. Auth0 is like a giant rule engine. It's kind of like Okta, but not really. it allows you to take the user session. The user session has to pass through Auth0 for Auth0 to agree on the authentication. What you can do is you can rewrite any part of the authentication flow, which is very interesting. I would suggest strongly for you to take a look at the repository that I'm linking here. What you can do with the authentication when you use Auth0. You can basically take the user session and write arbitrary code to act on this session and decide if the user should be allowed, not allowed. You can change the user's identity, you can change the user's profile information, and so on and so forth. You can basically do anything that you want to the user's session, which is interesting. Here, just a very simple example of a function that decides on whenever someone should get access or not. It's like, hey, give me the groups, give me user groups, and if user is in those groups, let them in. Another feature that we wanted to enforce would be automatic access expiration. So as our director of security likes to say, use it or lose it. So what I mean is, every time you access any Mozilla system that opt in to the timestamping, to the automatic access expiration, your access is being timestamped. There is a database that stores the last time and date when you access this system, and there is a counter. Next time you access this system, Mozilla IAM is like, when was the last time Michał used MozDev? Okay, Michał used MozDev a week ago. Perfect, Michał is a regular user of MozDev. But if I stopped using MozDev for like half a year, the system will be like, where was the last time Michał tried to access it? And it would be like half a year ago. We kick everyone's session when we kill the account in MozDev for everyone who does not use it on a regular basis. So this is a very useful feature, because in an environment when you have like 60 or 100 different systems that you provide access to, it's very difficult to manage the problem. Hey, does this user still have access? Do I still need this access? Well, if they don't use it, they don't need it, so it's gonna expire, it goes away. It's like a very clean solution here. Another feature is a bunch of Oidc proxies. So we were trying to connect a bunch of systems that do not speak Oidc, which is one of the IAM protocols. We're trying to connect them to our system. But some applications do not speak either Oidc or some. So we were like, okay, we want our system to be able to be fronted with a proxy. So you have your application. In front of your application, you put a proxy that does authentication. And that's how you connect it to the single sign-on. So there's a bunch of them. There is like this identity-aware proxy from Google. It's free. You can use it. You basically put it in front of your application and boom, your application is Oidc compatible. So if you use GCP, I have no experience with it, but I know it exists. So I'm like, yeah, there it is. There is a similar service offered by AWS, and you have to use AWS load balancers. But Mozilla would not be Mozilla if we were not writing something on our own. So a friend of mine wrote a Nginx Lua OpenID Connect Access Proxy. That's a long name. And this proxy is basically a modified version of Nginx with like a bunch of Lua scripts that you can put in front of your application that is not Oidc compatible. And now it is, because users will be talking to your application for this proxy. It's very simple to deploy. It's open source. A link is at the top of the slide. Just use it. We used it for, well, kind of, for providing federated connection and SSO to things like command line applications, for example. Like Mozilla uses Mercurial for storing the Firefox source code. How do you make this one SSO? Well, quite simple. There is a modified version of the Mercurial client, which is a CLI client, a modified version of a CLI client. And we will not go in any details because it's super complicated. But basically, whenever you are a human using HG, use our own modified client that talks to your browser, opens a browser window. So when a developer wants to push something to HG, they start the HG client. The client is like, I have no session active. So it opens a browser window. You authenticate to our SSO mozilla.com. All the permission checks take place. The browser closes, returns the authentication token to your CLI client. The CLI client keeps this token for a couple of hours. You use the HG like normal, and maybe next day you have to relog in again. Similar stuff with Federated SSH. Also, the same friend of mine wrote it, kind of beyond corp Google style. If you want to SSH into a server, this is not something that Mozilla uses internally, but this is something that is, hey, there is a working piece of code. There is a way using the support that SSH has natively, the support for authenticating into servers using the OpenSSH CA. To connect your servers to single sign-on. So the way it works is kind of like this. You are trying to SSH into a server. You do it using an SSH access proxy. And the access proxy speaks to the Mozilla IAM. The IAM lets you in or not, returns the decision to the access proxy. And what it does under the hood is it issues you a temporary signed by Mozilla IAM certificate, and using this certificate you can access the server. The server knows about the same CA, so you can verify that the signature is valid. It's very similar to authenticating using the Kerberos, for example. It kind of gives you a ticket that you can reuse later. That would be what I have here, and I'm waiting for the questions, and I'm returning back to the studio.